So starting with the past paper pop quiz, this was a pop quiz, past paper pop quiz 4. Then question 1, a pendulum swings with a time period approximately 1 second. Describe how to use a stopwatch to determine the time period of a pendulum. So how we can use a stopwatch to determine the time period of the pendulum. So first thing what we will do, we will reset the stopwatch and we will mark mean and extreme position. Then we will record the time for, you can do for 20 oscillation, you can do for 10 oscillation, 15 oscillations. So record the time for 20 oscillations and divide the time period or a period of oscillation is equals to the total time divided by number of oscillations. So in this case, it will be divided by 20. So what we will do if we want the time period, the time it takes to oscillate. So one complete oscillation means it will move from one extreme position to another and then it return back. That is called one oscillation. So first we mark the mean and extreme position and we reset the stopwatch and we record the time for 20 oscillations. Because when we record the time for 20 oscillations, it will reduce the error due to the reaction time and as well as reduce the percentage uncertainty. Complete the table 2.1 by writing in each space of the right-hand column which one of the following device is used to measure the quantity on the left. So if you want to measure the volume of a water, so what we need to measure the volume, we need a measuring cylinder. Width of a small swimming pool. So if you want to measure the width,
Meter.
so in that case, a meter rule is suitable. Thickness of a piece of aluminium foil. Aluminium foil is very thin. So which instrument can be used?
Micrometers.
So we can use a micrometer screw gauge. What about the name of other apparatus which are used here? A digital balance we can use for the mass. Measuring cylinders for volume. Meter rule is for measuring a thickness or the length. Micrometer screw gauge is also for the thickness or the length, but that is very short distance or a length. Stopwatch is for the time. And thermocouple, it's used to measure a temperature. Thermocouple and thermometer used to measure the temperature. In question 2, tidal power derive most of its energy from the moon and a part of its energy from the sun. State one other source of power which derive its energy from the sun. So here we can write multiple answers. We can mention wind, we can mention wave. State one source of power which does not derive its energy from the sun. So which is not derived from the sun. So we can say geothermal, or we can also say nuclear. Like nuclear and a nuclear fuel which we use on Earth, it's not derived from the sun. Figure 3.1 shows the tidal is already written here. That's why the tidal is already written in the question. That's why you're not supposed to write tidal. Figure 3.1 shows a small water turbine driven by the tidal flow of a water to generate electrical power. Explain whether this method of generating electrical power is renewable or non-renewable.
Renewable.
Explain whether this method, so what is this? This is renewable, just now. And why we say it is renewable? Because the rate of a consumption is lower than rate of formation. Like the rate at which this energy resource produce is much higher as compared to as rate at which we consume. That's why we call this as a renewable energy resource. So you can also say renewable because a large amount is available. That's also you can say that. That's fine. And the next, the mass of a water passes through the turbine each second is 6 exponent 3 kilogram. This is a mass, and how much time is there? Each second means 1 second. The speed of a water is 2 meter per second. That's a speed given. 40% of the kinetic energy is converted into electrical energy. Calculate the electrical power. So first we write the formula for efficiency.
Sir, I will convert kilogram to gram or
No, it's SI unit is kg.
Divide by output. Multiply
So efficiency, the formula of efficiency can be in terms of power or it can be in terms of energy. We can also write, like, we can say efficiency is equals to useful output divided by total input times 100. What about the useful output? What about the useful output? Because it is producing electrical energy. So useful output is electrical. What about the input energy? Input energy is the kinetic energy. So efficiency, it's already given to us 40%. So we have the value of N. The useful output, because it is giving us electrical energy, so I'm writing E dot E means electrical energy, and the input energy is the kinetic energy times 100. Because the turbine rotate and it produces electricity. So what is the input energy? Input energy is the rotation, kinetic energy, the motion. And what is the output energy? The output energy is the electrical energy. So we just substitute these values. Efficiency is 40, so we can put 40 here. Electrical energy. But we need electrical power. Keep one thing in mind. So electrical energy, we don't know. What about the kinetic energy? The formula for kinetic energy is half mv square. You can separately work out the kinetic energy and then substitute the value. Like kinetic energy is 1 by 2 mv square. So 1 by 2. What about the mass? The mass is 6 into 10 to the power 3. The mass is 6 into 10 to the power 3 multiplied by speed is 2 square. So when you simplify this, the kinetic energy, so this will be 12 into 10 to the power 3. That will be the kinetic energy. So the kinetic energy is 12 into 10 to the power 3 multiplied by 100. Now you need the electrical energy first and then we'll find the electrical power. So 12 into 10 to the power 3 is divided, other side it will be multiplied. So it will be 40 multiplied by 12 into 10 to the power 3, which is 12,000 divided by 100. So what is the answer? 12,000 into 40 divided by 100.
sorry.
12,000 because 12 exponent 3 means 12,000 times 40.
Sir, 4,800.
4,800.
Okay. So this is 4,800 electrical energy. But we need the power in the question. We need the power. Power is energy divided by time. The symbol at the start is the efficiency. That is N, used for efficiency, which is a useful output divided by total input into 100. So if you need the power is energy divided by time. Energy, we work out 4,200 and the time is 1. So how we know time is 1? Because they mention here each second means 1 second. This much mass flow. So 4,800 divided by 1, we get the 4,800 and the unit will be watt. Whenever you see a 4-mark question, what does it mean? It means you will always use two formulas to solve. There are always two formulas involved to solve. What are the two formulas involved here to solve? One is about the efficiency we use. Another was a substitution of the kinetic energy. So whenever a 4-mark question is there, it always means you have to use two formulas. Is it clear, this one? Next question 3. Two pans containing water are placed on a hot plate of an electric cooker as shown in figure 5.1. The hot plates are switched on and the temperature of a water in the pan start to increase because the pan will take energy by conduction from hot plate and then it will transfer that energy to a water and that will within the water it will transfer by convection. When the temperature of a water is below 100, some of the water evaporates. At 100, the water start to boil and the temperature remain constant. Whenever there is a change in state, there is no change in temperature. If a substance is melting, there is no change in temperature, or it is boiling, there is no change in temperature. State and explain which pan has a greater rate of evaporation when both pans were at the same temperature. The both pans of water are at the same temperature. So which one will have a greater rate of evaporation?
Large one.
Large pan. Why large pan will have a greater rate of evaporation?
Because
Because
More
large
surface.
good. Because it will have a large surface area, that's why the greater rate of evaporation. Apart from the temperature at which it occurs, state how boiling differ from evaporation. What is the difference between boiling and evaporation? Many differences are there other than the temperature, because temperature they already specified that the boiling temperature does not change. So what else we can say in a boiling?
Sir, in boiling, it happens throughout liquid while evaporation happens only at the surface.
Yeah, so you can say boiling happen throughout the liquid, evaporation occur only at the surface, or in during a boiling the bubbles will form and evaporation no bubbles form. When the water is boiling, the thermal energy being supplied to a water at a rate of 920 watt. What is the meaning of 920 watts? Boiling occur at 100 degrees centigrade. That is specific for water, and you're not supposed to say anything related to water because anything related to temperature of the water, because they already mention here apart from a temperature at which it occur. So that you cannot say. So you cannot say boiling occur at 100 degrees. That will not be acceptable answer, as they already specify that you apart from a temperature. Other than temperature, state the differences. Explain the effect on the molecule of a thermal energy being supplied. So when we supply a thermal energy at a rate of 920 watt, it means 920 joules is supplied to every second to break the intermolecular forces. So state the effect on the molecule of 920 joules of energy is supplied every second to break the intermolecular forces. So the molecules move apart from each other. That is what we are supposed to write.